In this video, we're going to demonstrate the difference between Docker and Kubernetes and how they run containers, and really try to show you how Kubernetes adds a layer of abstraction to allow you to run multiple containers in a more efficient way. So if you want to follow along, you can go to killercoda.com/playgrounds/scenario/Kubernetes, and you can run these same commands. So first, running a Docker container is pretty simple. We can do docker run and run it in daemon mode or in the background. And we'll just name this container docker success. And then we'll expose port 80 on the container to port 80 on the host machine, or this machine that we're running on right now. And then the image that I'm going to use is my own image. So that's under my username in Docker Hub, and then docker-success, and gave it the v1 tag. So it's going to go ahead and download this image and run it on this local machine here. So now if we run docker ps, we see this container running, and we can go to port 80 on this machine. In the upper right-hand corner, there's a hamburger menu, and we can go to traffic/ports, and then we'll click on 80, and then here we go. It works on Docker. So this container is running in Docker, and then now that we have a container running in Docker, let's go ahead and run a container in Kubernetes. So let's clear the screen here. And we could do k-create deploy, which is short for deployment. And the K is an alias to kubectl. So kubectl is how we interact with Kubernetes and the Kubernetes API. And then we'll give it a name. We'll call this Kate Success, which is the name for our deployment. And then we'll use the image Chad M. Crowell / Kate Success v1. And so now that we have a deployment, we can expose that deployment and create a service. So k-expose deploy. And our name of our deployment was Kate Success. And then we'll expose it on port 80. And then the type will be node port. So now we can do kubectl get services, or SVC for short. And now we see this is running on node port 32131. So we'll just copy that. And again, go to traffic/ports. And in the custom ports, we'll paste in that node port address and click on access. And there we go. It works on Kubernetes too. And so here's the difference between the Docker container, so docker ps again, and we'll see that Docker container running and also that Kubernetes container. One of the issues that comes up here in Docker is exposing ports on the host. As you see here, we have port 80 exposed on the host. So if we try to run that same container, let's name it something different. So docker success 2. We'll get the message port is already allocated, right? So we can't expose 2 containers on port 80 from our host, and I think your argument to that would be, you can just pick a different port, like 8080, for example, and we have to give it a new name. And so now we've kind of solved that problem by, instead of exposing port 80, exposing port 8080, but you still have the issue of only being able to utilize a certain number of ports, right? There's going to be a time where you run out of ports and you're not able to run, hundreds or thousands of different containers on that host or across many hosts, right? So this is where Kubernetes comes into play, where you're able to run multiple containers inside of a pod, which allow us to create our own kind of virtual environment for that container, which allows it to run independently of other containers so they can request the same port many times over and over again. And so we could see that if we run that same command to create a deployment. So we'll create a deployment and we'll give it a different name. And then we'll expose that deployment again, and using the same port, which is the key here. And we didn't have any problems, right? We didn't get that same message that said the container's port is already allocated. So we have Docker, which has one host and only a certain number of ports available. And then the container runs on that host. And no matter what port that container is exposed on or has exposed, so let's say you had two containers, both exposed port 80 on the host, only one of those containers can use it. And so you have a limitation there of only one port per host, right? Now what Kubernetes does is you have a pod which has a container within it. This pod is responsible for holding that network namespace. And as a result, this pod will always get a unique IP address and a DNS name, effectively rendering it its own isolated unit, and therefore not having to rely on the host, the underlying host. So you can have multiple pods, each exposing their own port 80, and they can all be on the same host if you want. Or because pods are not necessarily coupled to a host, they can move around to any infrastructure and still operate within that same isolated environment.